guys, today we're going to be learning about finding the graphs of rational functions. Now, in order to do this, we have to look at our original problem. As you can see on the board, we have written out a very long and complicated problem, and I'm going to be showing you a step-by-step process of going through and finding all of the components necessary to graph this correctly. The first thing we're going to be looking at are the wholes. And a whole is whenever you can cancel a rational function in the binomial on the numerator and the denominator. So we're going to be looking for any kind of variable that is the same both in the numerator and denominator. If we look at our original problem, we can see that x plus 5 is exactly what we need. It is both the same in the numerator and denominator, which means that we can cross it off and use it to find what our whole will be. Now with our x plus 5, we're going to be setting it equal to 0 in order to find what the x variable will be. Whenever we do that, we subtract 5 on both sides, and we will find that our x equals negative 5. Now that we have our x coordinate, we can use that to find our y coordinate. We will be using the x equals negative 5 back in our original problem, and we'll just be plugging in negative 5 to each x variable in the original problem. Now when we do this, in the numerator, we will have negative 5, in parentheses negative 5 plus 1, and in parentheses negative 5 minus 3. In our denominator, we will have negative 5 plus 7, negative 5 minus 7, and negative 5 plus 1. Whenever we solve all of this out, we will receive a numerator that equals negative 120 and a denominator that equals 56. When we plug this into our calculator, we will find our y-coordinate to equal negative 2.14. Now that we have our x being negative 5 and our y being negative 2.14, that is our whole. So when we go into later steps of graphing, that is what we will plug in just onto our graph, and we will place a hole in that spot. A hole and a point are slightly different. In the next step, we will be finding all of the points, but for the holes, it just means that the graph cannot equal that one specific place. Therefore, we will draw a circle that we will not fill in because it is a hole rather than a point. The next step in this process is finding the roots or the zeros. These are basically just the points on our graph. In order to do this, we are using our numerator to find where the function crosses the x-axis. The x will always have a number, but the y-coordinate will always equal 0. In order to solve this, we're just going to get each variable in our numerator and set it equal to 0. So if we look at our original problem, in the numerator we have an x, which will equal 0, and then we have an x minus 1, which will also equal 0. But in order to solve that, we have to add 1 on both sides. We will find that our second x equals positive 1. And in our third variable, we have an x minus 3. Whenever we add 3 to both sides, we will find our x to equal positive 3. Now those are the three variables that we will be setting equal to 0 in our numerator, and we will find our three x's to equal 0, 1, and positive 3. The third step in solving our problem is going to be looking at our vertical asymptotes. A vertical asymptote is a section of our graph where the line cannot touch. So a vertical asymptote will be a dotted up and down line where our graph is going to be restricted from passing unless there is a point present. The process in order to find the vertical asymptotes is very similar to step 2, except we will be referencing our denominator instead of our numerator. In doing this, we will get each section of our original problem and set it equal to 0. Our three variables, which are x plus 1, x plus 7, and x minus 7, we will be setting equal to 0, and we will be solving each of these. As you can see in the x plus 1, we add 1 to both sides and find our x to equal negative 1. In our second, we have x plus 7. When we subtract 7 to both sides, we find our x to equal negative 7. And in our third section, we have x minus 7. We will add 7 to both sides and find that x equals positive 7. Our 3 points to find our vertical asymptotes will be negative 7, positive 7, and negative 1. The next step in finding vertical asymptotes is going to be finding where our limits are. In this, we are going to find if our graph starts from negative infinity or positive infinity. This is a very important section of graphing because if you do this incorrectly, it will throw the entire problem off. It is very important to do this part correctly. In order to find where your limit lies, we'll be looking at the right side of our problem. We will choose one of the sections of the denominator, and in our problem we will use the x equals 7. We want to find a number that is slightly larger than positive 7, which in this case we'll use 7.1. Whenever we do this, we will simply plug in 7.1 to each x variable in our original problem. So we will have 7.1 and then 7.1 plus 1 and 7.1 minus 3 in our numerator. And in the denominator, we will have 7.1 plus 7, 7.1 minus 7, and 7.1 plus 1. Now, whenever we are solving this, we don't have to find an actual number, but rather if it is going to be a positive number or a negative number. If we look at our numerator, all three binomials will equal positives, and all three variables in our denominator will also equal positives. Therefore, we know that our graph will ascend from positive infinity. The fourth step in solving our problem is going to be finding the horizontal asymptotes. The horizontal asymptotes are very similar to vertical asymptotes in that they are dotted lines where the graph cannot pass without a root present. In order to solve this, it is a very different process. We are simply going to be looking at our original equation and counting the number of x's in our numerator and denominator. Now, depending on if the degree of the numerator is less than, greater than, or equal to, it will change what our horizontal asymptote will be. If the degrees of the numerator are less than the denominator, the limit will be 0, and if the degrees of the numerator are greater than the degrees of the denominator, it will not exist. If the numerator has an equal amount of degrees as the denominator, then you will simply place the degrees of the numerator over the denominator and reduce to get a fraction. That is the process that we will take in this problem, because if you count the number of x's in the numerator and denominator, they are both 3. Because x to the third is equal to x to the third, we will get the highest numbered numerator and the highest numbered degree denominator and put them over each other. In this problem, it will come out to be 1 over 1, which will make our horizontal asymptote equal to 1. The final step in solving this will just be to graph all of the information we have calculated. Just to recap, we have found that we have one hole and it is at -5, -2.14. We also have a roots at x equals 0, 1, and 3, and we have a vertical asymptote at -7, +7, and -1. Our only horizontal asymptote is at +1, and our graph will be ranging from positive infinity. That is a summary of steps 1 through 4, and with this information, we can properly begin to graph. What we want to do is simply just lay out all the information we have found, starting with our asymptotes. We will first put our horizontal asymptote at +1. We will also put our vertical asymptotes at -7, +7, and -1. With that in mind, we can now look at our points and our holes. We are going to be putting in our roots on 0 because we know that the y-coordinate will always equal 0 for our roots. We are going to be placing them at 0, 1, and 3, and we will basically represent them with a point that is filled in. When we graph our holes, we will be placing it at our x and y coordinate, which is -5, -2.14, and we will represent that with a hole that is not filled in. That way it represents our hole and that our graph cannot equal that point. Now, whenever we found our limits, we found that it ranged from positive infinity on our right side. So when we graph this, we look at our graph from the furthest right side, and we can begin to draw our line going from positive infinity. It will move straight down, but whenever the horizontal asymptote, which is at +1, begins to get in the way, our graph will curve and move in the other direction. The way asymptotes work is with each asymptote, whenever one line on one side goes from a positive infinity, the graph starting from the other side of the same asymptote will move from negative infinity. That's why on the graph next to the furthest right side, we will begin from negative infinity, moving upwards until we reach our first point, which will be at +3. We can move through +3, and we will be moving our graph down to our next point, which will be -1, and then back to our next point, which is 0. We will make a type of zigzag movement, and because of where these points lie on our graph, we know that it will be moving through our asymptote. The only time when a line can move through an asymptote is when a point is present, and because of that, our line will move upwards through the asymptote towards positive infinity. Because of the rule where when you move up from positive infinity, the next line will begin from negative infinity, our next line will be moving from negative infinity. We will be moving in a kind of like a upside down U shape because there is no hole to allow us to pass through the asymptote. So our line will curve at the horizontal asymptote begin to move back down and hit through our hole. So we will draw a line that passes to our hole but not through the hole, because a hole is where a point cannot equal. This graph will be ending and beginning at negative infinity. And that is important to note because of the asymptote rule, it will be our next line beginning from positive infinity. This line will be ascending from positive infinity, and it will be stopped at our horizontal asymptote because there is not a point to allow it to pass through. And it will have a very similar appearance to the first line that we graphed at the very beginning of this graph. I hope that you have found this helpful. This is the step-by-step process to find the holes, roots, vertical asymptotes, and horizontal asymptotes in order to graph a rational function correctly. I hope you guys have found this useful, and thank you so much for listening.